we lose some people now? We lost some people?
That's okay. I think we're still okay. Okay, so go ahead, Dr. Tung.
All right, thank you, everyone. Well, this is the first time we're doing this, so there may be some technical issue we need to be aware of next time. We'll do this again. So now, basically, before I do a live demo, I just give you a quick background introduction on DynuStudio. So I guess most of you or all of you are currently DynusT users and also using Nexta for your modeling effort. And so you must experience some of the shortcomings of Nexta. And also I have the same experience because in early last year when I started to work on a DynusT project, I was trying to use DynusT to do a full-blown regional model integration. But the concept is to integrate using DynusT to create dynamic travel time schemes and use that scheme to feedback to a full-stack model. And the concept is to trying to replace the static assignment module with the dynamic assignment module. But in doing that, I found out that DynusT just especially the GUI side, the Nexta, just cannot handle a large network efficiently. So it's kind of slow and very frustrated, and so then I started to engage in this effort, trying to design new GUI, because I've been writing software, basically demand model software for the past at least 20 years. And I have a product, and although it's not popular in U.S., but I do accumulate quite a bit of GUI developer experience. So that's what I'm trying to do here, and to use my GUI experience and in combination with the probably is one of the best DTA algorithm out there, and so the combination of these two probably will be a very useful system for the dynamic modeling. So before I start engaging in this GUI development effort, I kind of did a quick survey and to see what are the needs in a new GUI. So this is kind of this I compiled. So the first, we need a GUI can handle large network efficiently, because nowadays most people are trying to use dynamic DTA for a large regional network, and this regional network can be 1,000 links, several thousand zones, and several million vehicles. And if the GUI cannot handle this, although we know DynusT itself can handle a large network, but if the GUI cannot handle a large network, then the DynusT basically probably is rendered DynusT is useless in many cases. And also, we need a GUI who can retain the true GIS coordinates, as you experienced in DynusT Nexta. When you create a network in Nexta, you kind of create its own coordinate system. That system, as a person haven't figured out what's the relationship in that system with the existing GIS coordinate system. So when you trying to export out your network, DynusT network for other applications, the coordinates is a hassle to trying to match the coordinates. And also, we need a GUI we can do a better scenario management. Right now, Nexta basically has no scenario management. So basically, you just create a folder by folder and by itself, and it's hard to share files in between them. And so it has kind of redundant of the files floating between projects. And also, you're able to add a network and create scenarios easily, because for DTA modeling, certainly we have many scenarios we like to perform. For example, the tolling, work zones, and as a standard, the DynusT application scenarios. It has like evacuation, variable signs, ramp metering, all these other scenarios. We need to be able to create those scenarios easily. And also, certainly, we like to view and also compare results easily. So when you have scenarios, and then we want to see what the differences in results when you are adding the tolls to a link, to a bridge, and then you want to see where the traffic got diverted from the existing routes. And also, most important, people like to visualize the vehicle trajectory in details. So the beauty of a DTA is to create those vehicle trajectory. So you can see exact path of each vehicle that traverse. In the static model, we are not able to do this, and in the DTA model, each path is stored there, so it has all those detailed information, and we need to be able to visualize and have a good tool to visualize those information in details. And also, we need to have a GUI able to perform some of the select analysis. For example, select link analysis, select zone analysis, and select vehicle analysis. All these analysis tools are helping people to debug your network and debug your issues, your scenarios. And also, we also like to have a GUI we can script for custom data manipulation. So many modelers they like to script, they like to develop their own calculation modules. So to do some custom data manipulation. In DTA modeling, comparing to static modeling, they are more complicated in data sets, and also there are more attributes to be manipulated. You can manipulate. Okay, so this basically is where the DynuStudio is trying to address these shortcomings of existing Nexta. That's the first most important incentive, motivation to develop a new GUI. Now, secondly, certainly, we like to unleash DynusT power. You know, DynusT has been developed under development at least for the past 10, 15 years using the federal grant. Dr. Chu has invested a lot of effort and thought into this project, and as I understand, it's probably the best DTA simulation model out there in comparing to other commercial tools. And this is the only tool, only simulation model can handle long period simulation. For example, 24-hour simulation. And so Dr. Chu has invented some very smart algorithm trying to speed up those mesoscopic simulation algorithm. So that's before, for example, lately in his latest version, you can perform a 24-hour simulation for example, 10 million vehicles within the 24 hours in a day to get the results. Before, some of the conventional software probably won't be even able to perform a long period simulation. For example, this 24 hours, and also can take long, for example, multiple days to get results. But the DynusT now can perform a large simulation, 24-hour simulation, within a day. So that's kind of what most models like to have that feature, because most models are not very patient. So they like to get the results as quickly as possible. I think in a day that's probably the best situation. If we wait for multiple days to get results, then they will lose the interest in using the tool. And when you do 24-hour long period simulation, certainly you like to perform the dynamic time of day analysis. So that's the beauty of DTA. We can have a departure profile, and also we can generate arrival profiles. So with these two profiles together, then we can know exactly what the delays are changing throughout the day. In the old days, the traditional static model, we do create a departure profile, but we never can get the arrival profile to analyze what the true delay pattern look like during the day. So the beauty of DTA can do that, to generate arrival profiles. And also the transit simulation, the latest DynusT development has added a transit simulation module. Though the module is still under test, but eventually this module will be integrated in DynuStudio. So you can have a complete multimodal dynamic simulation. And also dynamic OD calibration. DynuST has a lot of tools has developed on this regard, and this dynamic OD calibration eventually will be integrated in DynuStudio too. And the sub-area analysis and the integration with micro models, I think certainly this will, a lot of applications would like to do this kind of micro model integration. For example, cut a small area and then export the results to, for example, the sim when they do more detailed simulation. But now, since the coordinate, we have a true GIS coordinates, then this its integration effort will be much easier. And also, integration with move. And the beauty of DTA is to create dynamic, more realistic speed patterns information on the network. And this information are required to generate the gas emission, those air pollution data. So the move, so the data can generate it from DynusT, then can be export to move, and once move generate their results, and these results will coming back to DynuStudio and to be visualized. So this part of integration is also will be part of the DynuStudio in the future, and also integration with four-step model. And certainly the DynusT can create a dynamic scheme, more realistic travel time scheme, and then this information that can be feedback to the four-step model. And I know some people, they want to stick with their four-step model framework, but they don't like the static the travel time scheme, so they can use this approach to improve their existing four-step model. Certainly, ultimately, you like to integrate with the activity-based models with DTA. So this effort actually already been under development. Dr. Chu already has a project on this part. And the advantage of the DynuStudio certainly is that it's tightly integrated with DynusT. It's written in C++ code with low overhead. I don't use very fancy those library, graphic library. So the overhead, memory overhead is a little bit less. And also, it's a multi-threaded program, so I use multi-threading whenever it's necessary to speed up the data manipulation, import, export, and calculation. And also, it has embedded the Python scripting and the API, so you can access the internal database and do your custom manipulation. And also, it has built-in the network and the GIS calculator, and certainly. I'm coming from the demand model background, so when I design this software, I also bring in those demand model experience. So the transition to static model from static model certainly will be easy. All right, let me close down and give you some of the program demo. All right. Okay, now, before I start, Any questions so far? If no, I will do this a live demo. This is a small network first. This is a network from one of the previous projects. It's a Guam network. So as you can see, the program is designed first with to highlight with for example, the display.
Sorry, Dr. Tung?
Yes. What?
Dr. Tung? Sorry, we still see your PowerPoint slides.
Oh, really? Okay, sorry.
Yes.
Let me switch my application. All right, I see.
There, we can see it now.
Okay, sorry. Okay, so this is a small-scale network, and also, as you can see, I designed a program in the display layer in layer structure. It's like a typical GIS application. You have layers. You can change the display order. For example, you can drag this down. So the linked layer will be displayed. So display will be at the bottom of the display layer, and all the essential attributes for DynusT modeling you can display quickly. For example, you can display the destination zone. So here displayed where are the destination nodes actually, because in DynusT we're converting from centroids to destination nodes and generation links. So all trips, all vehicles will be ended at a node, and all trips will be starting from a link, generation link. So here you can view where are the destination nodes you assign to. So I have, for example, the yellow lines here are your existing centroid connectors, but it's been disabled once you convert into DynusT or DynuStudio. But now all these red dots, for example, this zone is zone 68, so they are associating with 3 destination nodes. And these nodes you can change, you can assign to any nodes you want, as long as then you just basically just each node you can assign up to 5 zones. For example, let's take a look at what the data looks like. For example, this is a node, so I reserve 5 spots, okay, on the link on the node table. So you can assign 5 zones to this node. So right now, only one zone, 68, is assigned to this node as the destination node. Okay. And also, let's turn this off, and we can turn on the generation links. So here, show you where are the best generation links for a zone. For example, this is the same zone, zone 68. So it has a more 1, 2, 3, 4, 5, 6 generation links associated with it. So and each link has its own loading factor. For example, 34 here, 15 here, 29 here, 9 here, 5 here, 8 there. So this factor add up to 100. So basically representing 30% of trips from zone 68 will be generated from this link. Okay. So but certainly the location of this the destination of this generation links, user you can modify it. But right now by default, when you're converting from existing demand model, they just convert your centroid approach, centroid connectors automatically to the connecting links. But once you're done that, then user can manually to modify this. what you modify basically is one of the link attributes. See, we have reserved 5 spots, 5 zones. So each link can be associated with 5 different zones. So in this case, for example, this link associated with is the southbound location associated with zone 67 and with 33% of the loading factor. And the northbound is 68, zone 68, and with 34% of the loading factor. So the database in DynuStudio is quite easy. Basically, you maintain a node table and a link table. So on the link table, we have a number of reserved fields. For example, you have stream name, the link length, link type, and the left node number, through node number, right node number, and other one are the 2 node numbers, number of lanes, and the left-hand base, and the number of the left-hand base and the right-hand base, and the U-turn speed. All these attributes that you probably are familiar with if you use if you are current Nexta and the DynusT users, and also the traffic flow model and the generation zones, all this information. Then on the node table, the same thing. We also reserve a number of attributes. But in here, one of the important things is in DynuStudio, I do enforce the node orientation, node direction. Right now in DynusT, you only identify the movement. For example, you have left turn, right turn, through movement. But you don't know this movement now in what direction. For example, we cannot identify northbound right turn, northbound left turn, northbound through, something like that. In the standard practice, for example, when you're building a single database or building other traffic analysis model, you do have those information, the node directional information. So here, I like to retain those information. Sorry. So the node directional information. So once you have this information entered, then later on, it will be easy to debug the issues, or easy to import, export, exchange information with other models, other data sources. Okay, so let's go back. And so all these other information, and also certainly you can have a link type. So you can have assign different colors to represent the built-in DynusT link facility type. So you have freeway with ramp, so you can have these different color associated, and also you can turn the layer each type on and off if you don't want to show this. So you have the options, flexibility to do this. And so also we have reserved the data field for performing some of the scenario analysis. For example, doing the tolling, editing tolls. For example, if you want to add a toll for a certain link, okay, then basically you can just right-click here. You will pop out the window showing, okay, for this link, you want to apply a toll to this link, and what's your starting time? For example, let's say 0. Say okay, just say a starting time and ending time. Then what's the toll type? Distance base is a link base. Okay, then what's the toll amount? For example, I want to apply $10 to a SOV, and the same $10 to the truck. For example, this is and free for HOV. So when you enter this, by giving your value of time, $15 for LOV, and $10 for LOV, and $15 for HOV, $30 for a truck, then there's a calculation for the potential a time penalty will be added to that particular trip using that particular link. So there will be 60 minutes equivalent for a LOV and the 20 minutes equivalent for the truck. So if you like this setting, and you can just add this new entry, okay. So you can do this for the multiple time period and the multiple different values for different times. So this is the scenario creation and also the editing. And the same thing, you can do the same thing for walk zone. The same as can be applied to walk zone, incidence, ramp meter, and potentially other scenarios. So we probably DynusT will be adding later on. Okay, so once you've done this, and then you do then you finish your network editing. Then you can do the simulation. So all this is the centralized control box. So you can identify specify what's your planning horizon and the assignment method, and also what's your traffic flow model table you want to use. And so these are some of the settings that DynusT requires, and also the advanced parameters. You can specify how many threads you want to use for this simulation, and so all this can be accessed from this box. And also whether you want to turn your scenario testing on or off. For example, pricing tolling. Right now I turn it off, but then you can pick which table you want to use later on. Incidence, work zone, variable sign, ramp meter. Okay, all these can be set up here, and also DynuStudio. Okay, it's a GUI. It's a front end to DynusT algorithm. So here basically, before you perform the DynusT simulation, DynuStudio will export out all this, your network modification, all these settings into a standard DynusT input file, those DAT files, automatically. Then, so in the meantime, you can choose which DynusT executable you want to use. So here you can associate DynuStudio with your, for example, with your existing the DynusT executable. And for example, you can use whether it's a 32-bit or 64-bit, for example, to use. Okay, so then it will automatically run the simulation using that executable for you. Okay, once you've done the simulation, then we can do some visualization. Here we have a number of tools to help you. For example, first is the individual link profile. Here you can pick a node in all the approach links. So will be displayed here. In this case, there are 3 approach links, and each approach link, the total volume distribution through your simulation period, this is by 1 minute interval, will be displayed. And you can pick different performance measures. Those are the link-based data. For example, the density information for different links, and the speed information. For example, the speed is up here and then going down as the network is loaded. So it's slowing down and coming back. Okay, it's just the opposite to the density. So this is for the individual link. Okay, so you can pick a different link, give you a quick view of your results. Okay, and then you can have this animated bandwidth display. Okay, let's just move out this, make the larger screen. Okay. So first, let's show showing the volume bandwidth. Okay. So you can see that it's a play it will showing the bandwidth changes minute by minute. In this, actually, this case is a 6-second by 6-second interval. Okay, and you can say same thing. You can do the same thing for the showing the density, link density changes throughout the simulation period. So here you can see the color are changing according to these intervals. So darker the color indicating there are high density on that link. High density also means they are a congested link. And also, for instance, if you see your density greater than 100, certainly that's almost a stop-and-go situation. And this can be, you can play back and forth if you want. And also, it allows you to save your current results into an output field. So then you can use that output data to export out or for other purpose, to be used for other purpose. And once you can also doing this for this speed data. Okay, so let's say speed data. So certainly it's the same thing. The darker the color is, the slower the speed is. So this will be a very helpful tool to debug your network and your simulation results. Then you can also compare your results against other scenario results. For example, I want to compare against that and use volume difference. Okay. Then you can see showing the difference between two scenarios. For example, if you're adding a toll or adding a work zone, what's the traffic of changes? So you can. So I'm showing if the positive difference using the showing in red and the negative difference showing in green. So this is give you a quick view of your scenario difference. For example, you want to see where the traffic is diverse, or but just want to know what's the difference if I'm doing this or if I'm doing that. Okay. Okay. Then you can have this diagram to showing your departure arrival profile. So there are several curves are showing here. We have a departure. Okay, so this is your departure profile for the 100 million simulation. So actually, your demand, well, I only have a 60-minute demand. So your demand ended at 60 minutes. So there will be drop, no demand. But then here is your arrival profile. Then your vehicle keep arriving to destination zone. So continue through the entire 100 million simulation period. Then certainly there are some traffic are not finished. So you can see there are some traffic not finished. And so in this case, 66% of traffic are not finished. And also showing the average delay by the departure time, and also every trip time. Okay, for each vehicle. So this is imagine if we do a 24-hour simulation, then you will see more detailed information here. Then you can do select link vehicle analysis here. Here, okay, you can do. Okay, so you can limit your search. For example, right now we are 100-minute simulation. Let's say I just want to show the first 60 minutes, first hour results. So let's say, so this is showing the results. Now the beauty here is we can show perform some select analysis. For example, I want to select a link showing the trips using a particular link. For example, I want to show you the trips using this link. Okay, the southbound link. Okay, let's copy this link number and paste in here. Then say query. So then here is showing all the traffic using that particular link. Then I want to further narrow down my search. For example, I want to show you another link. Okay, showing vehicle using two links together. Okay, for example, showing also using this link and also the southbound. Okay, select link plus. So adding these two link number together. Okay, so this is the pattern, the traffic flow pattern using all the vehicles using these two links together in the same path. So you can do this different combinations, and also by departure zones. So this is all these traffic coming out of zone 1. And the same thing, all the traffic going to zone 1. Okay, so it's basically reverse the direction of the traffic here. And so all these combinations, you can say you can limit it by time, limit it by vehicle type, by driver's class, departure zone, arrival zone, select link. So all these criteria filter can be all come together. So then to give you the flexibility to look really into the issues. What are your network look like in your simulation results, and also you can show no information. So here tells you your turning movement proportion. For example, your left turn is showing in red, a right turn is showing in green, a through is showing in yellow. So you can quickly identify, okay, at this particular node, what are the main turning movement, main movements. Okay, and also you can show okay, let's see, I don't show nodes. Okay, sure. Okay, I also able to show individual trajectory here. Okay. Okay, we are probably running behind. Let me speed up a little bit, showing the vehicle trajectory plot. Here you can see those vehicles moving. It's a dynamic snapshot of the vehicle movement. What we are seeing here is all the vehicles, highlighted in red is a SOV. Then you can have different modes in different color, and highlighted in dark color, in black, showing those are the cars. They are hitting the minimal speed, so basically are in the stop and go situation. So let's zoom in. And so doing that, you can change the symbol size. So apparently that's a little bit too big. Okay. We can even get a smaller size. All right. So then we can turn on the no delay. Here the circle represents the average delay for all the approaching vehicles at that node. So you can see the bigger the circle is there are more average delays. So this average delay is in proportion to the maximum delays. So for example, in this case, the maximum delay is 95 seconds, 97 seconds. So you can see then you can look for those bigger delays, bigger circle, and see what are going on there. So those are the potential hotspots for the congestion issues. So when you zoom out, then the symbol size will automatically adjust. Okay. And also you can perform the select a link analysis doing this way for the vehicle trajectory. So let's say I only want to show vehicles using a particular link. For example, in here I want the same thing. I want to show in the vehicle using that particular link. Okay. Okay, let's refresh, restart. So you can see those are the vehicles using traverse particular link. And also you can turn on the vehicle ID information. So they are plotting out the vehicle ID for you, so you can quickly identify. Oh, I'm interested in looking at what's the individual vehicle path look like for certain vehicles. Okay, so let's just randomly pick vehicles. For example, let's say vehicle 100. It may not pop up. Oh, that's one. Okay, 100 pop out there, but it's a short trips. So you just flash out quickly. Anyway, so here is so this tool can give you a pretty good ideas what can you do with to analyze your simulation results, and also you can show background. It basically just give you paint your background in a color, so so you only want to have those vehicle trajectories stand out, and you can also freeze your vehicle trajectory, so showing the trails of your vehicles. So you can see here, you can give you a kind of more like a static idea. Okay, so
excuse me.
Close down.
Excuse me, can you zoom in on one of the circle and one the trajectory again?
Oh, okay, sorry. You want to see more detail the vehicle trajectory?
Yeah.
Okay, all right. Okay, let's turn off some of these layers. Okay, let me just pick a.
Yeah, I have a question on the note on the left bottom corner.
You mean here?
Going down the other one.
This one?
Yeah. When you look at it, we have this stop and go vehicle leaving the intersection but not getting in. I'm just wondering why.
Well, actually, it's getting in, but it's just changing the colors. So only.
So the arrow side, the arrow is not direct. Is not identifying the direction.
It's direction. Yeah, it's direction.
But it's going eastbound.
Yeah, but this vehicle only hitting the minimum speed at this section, this spot. Then speed up, so changing to the red color.
So it's not really stop and go. It's just low speed, right?
That's right.
It's just speeding up from the intersection.
That's right. Yeah.
It's not really stop and go traffic.
It's just a slow speed, okay? Because when you define your traffic flow model, you define your free flow speed, your minimum speed. For example, okay, here you have your traffic flow model curve. Okay, you can define your alpha turn, beta turn, then there is your gene density. Then what's your minimum speed?
Yes.
So if a vehicle on this link hitting this minimum speed, I would use a dark color to highlight those vehicles.
Yeah, because I'm just wondering why we don't have to stop and go before the signal, but we have to stop and go after the signal. When they're approaching the zero, it should be stop and go, and then when they're leaving the signal, they're speeding up. But in this case, it's the other way around. Here we didn't see anything stop and go traffic when they arriving the signal. But we are seeing stop and go traffic leaving the signal.
Yeah, it may not be because the signal, the intersect, because there's a loading point somewhere here. For example, there's a loading point. So there's traffic generating from that point. That could cause you stop and go, not because your signal delay, maybe just the plan of your link delays.
Okay.
Because this minimum speed, the delay is coming from two sources. One is your signal delay. Another one is also your link delay. Okay, that's the Dr. will probably tell you that's the method Scott, because it was his algorithm, okay, calculating the delays. Okay. And also based on the density information. Okay?
Yep.
All right. Okay, I need to switch to another screen to show you the larger network. Can you switch to the next RST2?
Actually, RST2 is not available right now.
Oh,
you have to log into RST2 again.
All right, sorry, okay.
So what I think I need to do is I need to exit or dismiss RST and then go ahead and re-sign in with RST2. Okay? So as soon as you sign in, you should be able to see your screen, your RST2.
Okay, let me see what's your meeting ID. Okay, I'm logging as RST2 now.
Okay.
Do I need to give an email or not?
I would put one in just in case. Okay, it's showing that you've just arrived, so I'll go ahead and switch RST2 as presenter. Okay. Okay, we can see your screen now.
Okay, here is a larger network. Actually, this is a Portland Metro network. And also on the screen, you can see here is the Python. I have a Python manager and also the Python script editor. So you can use this tool to do your custom calculation. So all these syntax are highlighted in red color. Those are the built in the API code to access the internal database. Okay, here, okay, it's so it's a larger network. So let me just want to show you one of the animation results, the vehicle trajectory results. So it has they just limited this vehicle to 1 hour. So for a quick display. Okay, for now, let's just show all the vehicles. Okay. All right. So apparently, the vehicle, the dots are too small to see. So one thing you can do, I want to just paint the background with a color. So now you can see where are the delays, where are the intersection are located, highlighted. Okay, let's just use a bigger symbol size, for example. Okay, maybe we should zoom in a little bit more. Let's just zoom in a little bit more here, the downtown area. Okay, now you can see a bigger symbols. Okay, and then let's just zoom in even more. Now I can see the arrow signs. And you can, for example, I just want to show the HOV. So those are the HOV pattern, flow pattern. And then you can also show in the truck. Yeah, probably not too many trucks there. Okay, but you can see that. Okay. And okay, certainly you just want to show the HOV. Okay, that's pretty much I have for today. Certainly, there are a lot of other things that we can talk about. But if you are interested, certainly we can arrange another more sessions individually if you like. Okay, now I give you some time to answer questions. To ask the questions. Anyone has questions? I have to say this tool is still under development, so if you are interested, I can send you a trial version to use, and then if you like it, and certainly we can talk about how to purchase. Any questions? Well, if not, we can thank you, everyone.
Thank you.
If you have any feedback and comments, and we really appreciate that.
Yes, thank you very much, Dr. Tung, for giving us an overview and a demo of your latest developments of DynuStudio. As Dr. Tung mentioned, if there's any other questions, you could either contact him directly. There is a page on our website that gives some description of his workings with DynuStudio. It's under the news section of the website. Or you can contact us, dynusty@dynusty.net via email. So with that, thank you very much, Dr. Tung, and thank you everybody for sitting in, and thank you for being patient with some of our technical difficulties. Some of the other webinars, Dr. Tung, are you planning to present something similar as well?
Which one? Yes.
I believe we have one this Friday. Will you be presenting similar or the exact same thing?
Yes, similar. Probably will be more refined. Yeah.
Okay.
Yeah.
So if you have already signed up for any of those events, you pretty much will be seeing the same thing this Friday or some of the other preceding events for the DynusT webinar or DynuStudio webinar. So if there, but again, thank you very much, and you can contact us if you have any questions. Thank you.
All right, thank you, everyone.